be in the smartphone, it can be in your web browser, it can be on any device really. And so that's I think a nice way to think about the ways we can interact with data products. Now, if you put all of this together and you try and think about how can we combine these two perspective categories and types of interaction, you end up having basically 5 times 3 different possibilities. And I've tried to picture here what this implies. If, for example, you say, I want to create an application and I want to make it so that it's providing automated decisions. That, of course, is probably the highest complexity. It takes the highest effort to build something like this. And on the far end below, lower left corner, you could say, okay, I have some raw data and all I want to do is visualize that data somehow. And that's by now pretty easy. You can basically go online and upload your data set and you can provide some visualizations relatively quickly. And so, you know, when you're building a data product of some kind, you will ultimately have to make a decision on what you're building and to what extent you want to provide that. And this simple graph may help you, you know, have a guidance on where you stand. And obviously, once you start doing that, you will have to think about both business and technology, right? You will have to think about the strategy of how your data product will satisfy the needs of your users, of your stakeholders. If you're providing this as a business service, you have to think about how to monetize this. But obviously, you will also have to think about technology and how to enable your data product so that you can deliver it efficiently and effectively. And those are the 2 talks that we want to cover today. And with that, without much further ado, I give over to René, who will talk about data science strategy. René.
Thanks. Thanks, Patrick. So let me see whether I can share my screen. I think you first have to unshare and then you might be able to share. Yeah, looks good. Okay. Good. You should all be seeing my presentation. No, I don't see the rest anymore. But I think that's fine. Cool. Can I get a quick heads up whether everyone sees my presentation?
Yes, we can see your presentation.
Okay, excellent. Cool. Yeah. So thanks for the invitation. Thanks everyone for joining. We are around 25 people, so not too many. So from my point of view, also this is really not a, let's say, completely front-facing talk. I'd really like to have this more of a discussion. So please feel free to raise your hand or to just unmute yourself if this is possible. I don't know, and start talking whenever there's a question.
Yes, René, can I just interrupt you for a second? I think everyone should have the ability to unmute themselves. And if someone doesn't, please write it in the chat. I'll take care of it. So yeah, that's all.
Okay, cool. So yeah, so please just, you know, if you have a question or you have a comment, feel free. I'm also happy to get your insights. Cool. So yes, again, thank you. Maybe a little quick intro to myself. My name is René Pfitzner. I'm one of the co-founders of Xperify. We're actually building a service for people in order to be able to test products with other real customers in real life. Now you already see the problem, which is that in times of Corona, this is something that at the moment is a little bit halting, but still, so that's what we've been doing for the last year. Before this, I've been the lead data scientist at NZZ, Neue Zürcher Zeitung, the local newspaper here in Zurich. And there, basically, I've been responsible with the whole team of a very good analytics team to do things like marketing optimization. That's kind of, let's say, the classical issue, and B, the more, let's say, at least from my perspective, the more exciting things, which was building data products for content delivery, meaning personalization, meaning automated newsletters, and so on and so forth. So yeah, I've been doing this 4 years, and then basically since last year, I'm basically consulting companies in terms of how to build good data science strategies. That was before we started Xperify. Still doing this as a couple of side mandates, but basically the focus on Xperify. So yeah, so in this time I've been basically last year I've been helping 2 companies set up their data science departments, their data science strategies, and I think I can give a little bit of insights onto this. So yeah, so really what I want to do is talk about data science strategy and how to lastingly impact businesses. It's not kind of a big theoretic framework. It's really more like best practices and things I hear from other people, things I learned talking and basically implementing data science businesses. Cool. So yeah, and with this, I guess I'm going to start. Yeah, so the first question is why do first-time data science teams actually often fail? Well, the first question is, of course, is this true? So here's the thing. Unfortunately, I don't have any precise statistics on this. But actually talking to people and kind of observing the industry a little bit, it seems to be true. Let's say it needs a couple of iterations, or at least a lot of time of adjustment for data science teams to kind of find their fits within a company. So that's number one. And the second thing is really that it seems to be that, to me at least, that when data science projects, whatever exactly this may be, fail, they actually usually fail because of more, let's say, cultural reasons. It's very rarely kind of technical difficulties. Although, of course, also this happens, but especially when you set out the first, kind of the first time to implement a data science team in a company, there are many low-hanging fruits that you could actually pick. You don't have to reinvent the wheel. Also today, which is contrary to, let's say, 10 years ago, you don't need big technological upfront investments. You don't need to get a big Hadoop cluster on premise in order to do something, unless you're in a highly restricted environment. Basically, the only thing you need is, let's say, brain power and manpower and access to either AWS or Google Cloud, Dataproc, things like this, and you are basically ready to go. And most of the standard algorithms and things that are well known will do somewhat the job for you. But still, actually implementing the things that you've built as a data science team very often kind of fails at the let's say organizational level. So actually getting those data products that you built into use, and that's basically where we're going to be talking a little bit about. So I have a couple of reasons here that I quickly want to go through why it exactly is that first-time data science teams fail, or let's say data science strategies are not so successful maybe. And one is that people do not know what is possible with data science. And this is meant in a positive connotation and in a negative connotation. In the positive connotation, it's meant to in the way that people very often, let's say, underjudge what you actually can get out of data using smart techniques, how you can help with decision support and so on and so forth, how you can build more smart, intelligent products. So this is number one. And the second thing is, it's more kind of the negative thing, that there might be a mismatch in terms of expectation management, especially when, let's say, it's been a high-level decision that you want kind of a data science team, you wanted to roll out, and now with all the AI hype and a couple of companies basically selling the stars, so to say, with what you can do or what you will be able to do in the next 3 or 4 years with all this data. very often you have kind of a mismatch in terms of expectations and what is actually possible. And this more often than not then kind of leads to kind of a negative spiral, maybe, that, you know, people are actually dissatisfied after 2 years of a data science team. Oh my God, they haven't done anything. At least it seems like they only spend time implementing data. Well, yes, it takes time, but still. So basically being clear about what you can do and what you want to do is kind of very important. And one aspect that at the beginning is actually very often neglected. So this goes hand in hand with the second point that I want to make, is that successful data science strategies more often than not demand cultural change. So think about it. And this is really in contrast to, let's say, a IT department or any other department, classical department in a company that people know. They know, okay, there's an IT department, there's a marketing department, there's I don't know what department, and you kind of know exactly what they're gonna be doing. Very often with kind of a data science team, that is not so clear. So basically the things they build, let's say the dashboards that we heard about they build, or the smart APIs that they build in order to deliver intelligent insights, they are kind of new. So people need to get used to those things. They need to get used to the fact that you have within the company, suddenly you have capability to, let's say, maybe automate tasks. Okay, so for example, at NSET said one of the things was automating newsletters, and it basically took time in order to, let's say, educate people that, hey, we can actually do this. It will save you a lot of time. We can have more newsletters because of this, and so on and so forth. And to get people to a point where they actually, let's say, agree to this, and in the sense that they not only agree to say, yeah, I mean, you go on building and then we see, but they agree to it in the sense that, yes, we're going to do this together as kind of a joint project. Let's automate this and that task. Please, data science team, help me with that, or please do this for me. This needs cultural change. Also, so that's kind of one part of the cultural change, and it becomes also very apparent when we are thinking about dashboards, right? I mean, only having a dashboard available with all of the data most likely doesn't help. You need to form a habit. People need to form habits that they use it. People most likely need education and teaching on how to interpret the data, how to maybe even manipulate within the dashboard, if it's a bit of interactive, how to manipulate the data in order to come to more, let's say, self-service kind of analytics strategy. So this needs time, and this needs really kind of educational efforts, and those educational efforts, they need to come from you as a data science team. So that's the one part of cultural change. The second part where we need cultural changes, and I actually like to make this point often, is that it's called data science for a reason. Okay, it is not called well, I mean, sometimes, of course, you have people who do data engineering, but in general, if you have data science, there is a science component involved. What does this mean? It means that actually you okay, I'm a bit distracted here. Sorry. Yes, so it means that there is always a bit of uncertainty if you want to do things. Okay, so let's say you are thinking about, let's go back to the example of what we did at NSET, instead of building a recommender system. You have a good indication that with the data that you have, you'll be able to come up with something useful, but you don't know for sure, right? Or I don't know, let's say you want to build a whatever image recognition algorithm to get, I don't know, to, recognize certain patterns that are useful for this company. You have a good idea that it might be possible, or that it should be possible, but you never know exactly how and what's the precision and so on and so forth. So in this sense, you don't have a lot of certainty when you start out with a new, let's say, data science project. And this sounds a bit trivial now. You could say, yeah, I mean, of course, that's the case. But but the issue is that you need to think about how do people judge you and what do people think about you. And this actually comes into the second point. At the beginning, initially, when you start, everyone will consider you to be just another IT person, okay? So as a data science team, even if you are maybe not in the IT department, which in most cases I would highly recommend, and we talk about this a little bit later, people will consider you to be kind of an IT person, okay? And with this, basically, there come certain expectations, okay? So IT usually is kind of a service center, so people go there when they have problems, and then people will solve those problems. Or I don't know, you want to build a website or a new service, online service, you go to your IT department. The IT department makes a more or less detailed plan, and then of course with a lot of margin involved, you can be sure that what you want will be done, okay? It is an engineering challenge. So most of the things that people are used to when it comes to IT are, let's say, engineering challenges, okay? Things that most likely will be solved. And with data science, it's a little bit different. So you need a different mind frame. You need a different mindset when you're working with people on a data science project. Very often, basically, you have to educate people that, hey, at the beginning, this is a lot of exploration, and might be that we are working on this for, let's say, I don't know, 3 months, 4 months. And at the end, we realize that, hey, actually, it can't be done. And again, this may sound trivial, but it's actually kind of a very big issue, especially in a business setting where you do a lot of planning and so on and so forth. Okay, so it's those things really that this kind of mindset is important. The next thing that you shouldn't be, there's no disillusion here, is that when you start a data science team or you join one, and you're actually working with people out there in the company made for decision support or building awesome products, smart products together, chances are that there is someone or some particular, let's say, business unit that will consider you to be a threat. And I mean, this is, of course, on the one hand, this is fueled by what, let's say, the non-technical, non-data science person hears about artificial intelligence. That's like one thing. So that's kind of the let's say, more, the most severe issue when people think, hey, you're going to be stealing their jobs. That's like one thing. But it's also, on a more lower level that some people will actually not know how you can actually help them, and that you might just be yet another IT guy or girl who you have to work with. Okay, so it's those kind of things that might happen and that will happen, and that are a potential threat, basically, also to the success of you as a team. Okay, so now, of course, the question arises: well, how do you actually tackle all of those challenges, right? And you already see here, and it's basically on purpose. I'm not talking about any kind of technical issues because they can be solved, but it's all kind of, let's say, software issues. It's all about culture. It's about organizational setting, and the question is, okay, how do you get this right in order to kind of set up your data science team in such a way that it will bring lasting value to the company. And what I found is that basically, before you set out to kind of build up the team, and before you even set out to hire people, and that's very, very important, even before you hire people, you need to be clear as a business. And what is the purpose of this? Why do I actually want this data science team? Is it mainly because of analytics? Is it because I want, something like data-driven maintenance? What is it that you want to do? Because it will, of course, highly impact whom you hire. And the second thing is really the kind of, let's say, more softer success factors to kind of set them right. And what I mean by those, we're going to be seeing right now. Okay, so talking about purpose, we just heard about basically what data products can be and what's the broad spectrum, and this is also true for your general purpose as a data science team. Most likely it will fall somewhere in between here, or it will have basically, so it's basically 3 dimensions, and a couple of those dimensions, some more strong than others, will form the purpose, the basis of your data science team, right? So there's, on the one hand side, there's to be, let's say, a analytics and decision support provider, which is, you know, building dashboards, building reports, helping to interpret them. On the one hand side, that's kind of the let's say, very, let's say, hard hands-on doing part. On the other hand side, the education that comes with it, and to basically, you know, implement the what's very often called data-driven decision-making, data-driven thinking kind of culture into the company. So that most likely will be kind of one dimension of your purpose. The second dimension might be to build data-driven products. So here I'm saying data-driven products and not data products, because I want to distinguish that with data-driven products, I mean real, let's say, end products that you as a company maybe produce. In the case of NZZ, you provide information. So the question is, okay, how can you do this more smart? How can you do this more data-driven in order to, again, basically provide more customer value? So you might want to actually, or one of the purposes of your team might be to actually build those data-driven products. What does this mean? Apparently, it means that here you are not kind of a lonely player, right? You know, so it's not that you just start playing out an API, but once you have the API available that, let's say, provides personalized information, you need to work with the products department in order to see where you actually embed this API into your, in this case, news offering, or you know, or you also will have to work together with the marketing department in order to actually know, you know, how it's going to be used and so on and so forth, and how you might be actually promoting it such that you get maybe a learning data that you might need first in order to actually build a meaningful data product, and so, or in this case, data-driven product, and so on and so forth. So yeah, so that's kind of the second dimension. And then the third dimension might be that, and it's most likely will be the case also, that you will act as kind of a centralized, let's say, data provider to other business units. And there again, you have very different boundary conditions. So when, you know, I mean, there you're more in kind of a service provider role. So in this sense, basically, whatever you want to do will lie somewhere in this spectrum, and it needs very different skills and very different kind of also organizational settings to kind of achieve those goals. And that's kind of the second part is really success factors. So once you're clear about the purpose, you need to think about basically those 3 dimensions. It's people, what people do I need in order to actually achieve that specific business goal? Then the second thing is, okay, what kind of culture do I need there? So if your main purpose is, for example, analytics and decision support, the main culture that you want to be promoting is a culture of a data-driven decision making, you know, always using dashboards and so on and so forth. On the other hand side, when your purpose is to, let's say, build data-driven products and to make the products that your company produces or the services your company renders to make them more smart, then the cultural shift here is that you need to work together with the products department, and you might need to educate the products department to be a bit more, experimental, maybe a bit more risk-taking, in order to try out things, in order to get a little bit of data, in order to judge, what kind of things work for your customers and whatnot, and so on and so forth. And on the third part, there's the question of where are you situated as a data science team? So very often when people start building data science teams, the first thing that comes to mind is say, okay, let's actually start it as kind of a subunit of IT. It makes sense. I mean, IT is dealing with data. IT is most likely also the source of most of the data that you as a data science team will be consuming. Also, it's roughly the same kind of people. They kind of speak the same language. So it might make sense to actually put a data science team there. Well, unless your main purpose is to be kind of a smart data provider for, let's say, other independent units who consume that data. So unless this is the case, putting a data science team in the IT department is most likely the worst decision you can make. Why? Well, because if you are basically somewhere else, then at the point where you actually want to have impacts, let's say maybe can I quickly stop my Slack, because otherwise I'll be getting too much of those. So you want to be close basically to actually where the action happens, right? So when your purpose is to, again, this department is to actually optimize your marketing campaigns, it might be a good choice to actually put the data science team in the marketing department. Or if you want to build intelligent data-driven products, it might be a smart choice to actually put the data team in the marketing department. Okay, so all of those things you actually have to consider. And at the end, what I found really is that thinking in this kind of metrics is actually a good, let's say, way to go about it. And now I basically don't want to go through all of this, but again, maybe illustrate a little bit what I mean. And I did it already earlier, but just maybe a little bit more in detail, right? So let's say that your main purpose, or one of your purposes, is to be a analytics and decision support provider, right? Then in terms of people, what you want is, you want people who are very precise, who might have a, let's say, more of a service provider attitude, because people will come to you, they will ask you to, hey, can we do basically, can we do this and this analytics? Can I have this and this dashboard? So you want to hire people who actually have this kind of service attitude, and you want also people who are apparently good with numbers and who are also good teachers. So that's here. So this might be in contrast with, let's say, data-driven products people. So if again you might want to make the products or the services that your company renders smarter, you want to have people actually from the data science team working with people from the products department. So these need to be people who are, let's say, highly interested actually in building products, and not, let's say, just the technical issues, or not just crunching numbers. You need people who are highly collaborative, who are open to really new ways of thinking, because it will be a different culture. And most importantly, here you will need people who have a wide range of, let's say, data science knowledge, as opposed to, let's say, very precise specialists, for example, whom you might need here. Because here what you want is you want to have a person actually working with a products team and actually brainstorming what exactly they could do in order to, provide more value to their customers and so on and so forth. And the same holds true for the culture setting. So, for example, in the let's say analytics dimension, the culture you want to promote is a culture where you're actually going towards, let's say, more kind of a self-service attitude. So you need to have constant learning and so on and so forth. You need to teach people. Whereas here, basically, the culture that you want is more kind of an experimentation culture. And that's very different here, right? So in analytics, you want, let's say, precise numbers that you can actually use to base your decisions on. When you're building data-driven products, it might not be too important whether you measure all the page clicks correctly up to the very last one, because the data product that you are building might still work. And of course, also people need to be, let's say, comfortable with this, and that's kind of the culture setting. And of course, the same is true with the organizational setting. So here I basically already said, when you're building data-driven products, you want to be close to where the action happens. You want to be close to the products department or whoever will be using your services on the one hand side. Whereas here, when you're doing analytics or you're doing data provider, it might be much more beneficial that you are more kind of a central organ, more kind of a, let's say, more kind of a service desky kind of organization, somewhere really in the middle of the organization that is very well connected to basically everyone who is kind of interested in basically working with you. Yes. So that's basically the kind of mind frame that I found useful in order to, let's say, analyze what you want as a data science team and how you're going to do it. So now I just want to tell you a little bit. I don't have slides for this. I'm just going to do it like this, about two examples. So one example is NZZ, Neue Zürcher Zeitung. I said it earlier. They're basically the let's say analytics team. Again, for let's say historic reasons, was actually part of the marketing and products department, because there really the purpose was clear. The purpose was to help in decision support and automated decision support when it comes to marketing and marketing automation. That's number one. And the second thing was really to work with the products team in order to make the products smarter and to build smart media products. Okay, so and that was kind of the right setting there. Also, what was interesting there, as NZZ, I say, is kind of, let's say, is sufficiently small that even if you have, let's say, such a highly specialized team as an analytics team within a sub-department, in this case marketing and products, that other departments still will know you. Okay, so at NZZ I know it. It's still the case, and it's also there that the editorial office is, in a lot of touch with the data and data science team, and that they are also very closely working together. So this works nice there because the company is sufficiently small. Another example is another company that I worked with last year. There the setting was a little bit different. It's been a much bigger company, actually a bigger, let's say, almost kind of a holding company comprised of many other smaller entities. And there the goal was really to, let's say, build a data science team or a data science service center that can help basically not only the business units, but basically all those, let's say, sub-companies. So of course, this is a much more complex setting there. And in terms of purpose, what we wanted to do is to work together closely with all of the IT departments to basically be a, let's say, centralized data provider. So you basically had all those separated data buckets, and one purpose of this more centralized team was to be, let's say, the central hub in order to have all the data together on the one hand side. On the other hand side, also to actually provide analytics, dashboards, and decision support, and because this also has been a media company, to build data-driven products, however, for very different outlets. So there you kind of have this dilemma that on the one hand side, from an organizational setting, you actually want this organization to be somewhat at the center of this whole conglomerate. But on the other hand side, in order to build, let's say, data-driven products and to do this successfully, you need to have people with the right skill set, the data scientists, to be close to the products departments. And the way we actually solve this is that we set up the data science team as a competence center, which was really more, let's say, in kind of a central position. But then what we actually had is that we said, okay, we're having, so at the end it was a team of 12 people that was hired. You have actually dedicated data scientists, dedicated data science resources, in this case, more like the data science generalists, that you actually lend out to, in this case, product teams. And you lend them out not for a day or for 2 days, but actually for a longer period of time, mostly kind of 2 to 3 or even 4 months. And the reason you do this is that you say, hey, you know what? We have the people here. They have the data science knowledge. And what we want is to have them close to you and working with you. So basically for the period of the project, you become actually part of another team, in this case of, let's say, the product teams, and you're going to be working with them exclusively for basically this amount of time. And this actually had the advantage there that what you had by this is you had a rotational system that on the one hand side favored, let's say, information diffusion on the one hand side, and on the other hand side, you're not building things twice, right? So in this case, I said it already, it's been a media company, different outlets, very different newspapers, but still the kind of things that you want to build are very often very similar, right? So you want to build a recommender system, a article recommender system. You want to build a personalization system, whatever. So there actually you could kind of use those synergies and make sure that the different, let's say, subunits don't kind of reinvent the wheel, because you're basically using the same people from the data science team who you send out actually to the subunits in order to work with them and to actually build this. And they, of course, will have the knowledge of what already has been built and what is maybe already ready to use. So this was basically this kind of hybrid setting, and they've been doing this now for a year, and it's been working actually quite well. So this kind of rotational system is something that works. And also that's actually nothing that I invented. I know that, for example, Uber is doing this exactly like this. So I've been talking to some data science people at Uber a couple of years ago already. And I think back then they had like 250 data scientists. And what they basically did was this really super lean setting, as I just described it. Basically every 3 or 4 months as a data scientist, you would actually rotate and you would become part of another product team. Let's say the team that optimizes the routes, or the team that optimizes the payments, or whatever. So you would kind of basically do this, and it works very well. And that's actually also another interesting anecdote that Uber claimed, at least at that point in time, that they had a data scientist in every team. So no matter what, there was always and everywhere at least one data person involved. So in general, that's basically what I wanted to talk about and tell you. Yes, it's a bit weird, I must admit, to just be basically talking to myself without getting any feedback. I hope it's been of a little bit value, and yeah. So I mean, I'd be happy if we get into a discussion.
Okay, René, thanks a lot. I realized shortly after you started your talk that participants couldn't actually unmute themselves, but I solved that, I think, in due time. So now everybody should be able to ask a question by just finding the unmute button in the lower left corner and just unmuting yourself. If not, then raise your hand and I will manually unmute you. But to get the ball rolling, I'd like to start with a question first. Thanks for your talk. First of all, I found it very, very useful because as a data scientist, a lot of the things that somehow I intuitively felt or knew, you kind of really taxonomized very precisely, and then suddenly, you know, you see this light bulb that appears in your head. In particular, I mean, I never thought about this different focus of data science, you know, more analytics, more data-driven products, or as data provider. But I like it very much. And my question is concerns those three dimensions. Now, you mentioned in the very beginning that for each of these different, let's call them dimensions of what the data science team could be, you need to also define some kind of success factors, right? And I've found that it's very easy to define success factors if you can quantify things. And you can say, okay, I'm going to increase revenue by 10%. And then you can argue with another department who has 9%. And then you get more budget because you have 10%. But I found it very, very hard to do this in a data science team, no matter which dimension you take, analytics, data-driven products, or data provider. How do you go about that?
Yes,
or how do you define success factors in general?
Yes.
What would be good examples? Yeah.
Yes.
Thanks.
So now, also with danger of sounding a bit fluffy, but I'd say that especially for the analytics and decision support, your success factor ultimately is whether your stakeholders are satisfied. And this means whether they, and I know this is fluffy, but whether they feel that they can make better decisions. Okay. Because of course, I mean, especially with analytics and decision support, it's very hard to define, let's say, hard metrics, whether, you know, the dashboard you used actually had an impact. So at the end, I think it's a lot of soft factors there, whether people are happy with what you provide. Having said that, of course, there are always things how you can measure that. So, for example, if you're considering, or if you're thinking that you're providing, let's say, dashboards, rate of use of those dashboards might be a good hard quantitative factor to kind of analyze whether what you provide has value. And here, again, already you will realize that why I'm stressing actually all of those dimensions, because only building a nice dashboard or only building a nice, let's say, decision support system is only one part of the job. The other part of the job, and it's equally, if not even more important, is to actually get people to use it. And I found this to be really the one thing that many data science teams miss. They don't consider it their role to educate people and to kind of get this cultural change running, such that people, let's say, use the analytics. And it's actually the same with data products. So for example, at NSET said when we built the personalization system, I mean, only because suddenly you have personalized newsletters or a personalized newsstream, it doesn't mean that suddenly all of your customers, all of your readers in this case, will start using it. Actually, far from it. So you really have to have almost kind of, let's say, almost kind of a startup attitude where you know that whatever you build, you also need to promote. And you need to actually, actually help people doing this. So yeah, it's very hard to define, let's say, firsthand, or let's say, let's say, kind of hard factors who are kind of first order hard factors, but I think higher order hard factors you can define, like, rate of use for dashboards or rate of use of the data product that you built.
Got it. Thanks. We have a question from Mark. Mark, I'm going to unmute you. Go ahead.
Hi there, René. Thank you very much. Really, really interesting talk. And I fully agree with some of your findings there as well. One thing comes to mind that I'm not sure you touched on with especially larger organizations. Again, I fully agree with the idea of having data scientists close to the product, close to where it will be used, and close to where the subject matter experts are. But what you can end up with then, of course, is a number of distributed data science teams that don't talk to each other, that don't communicate with each other. And also you possibly struggle to have an oversight. And I'm wondering what you see as a possible solution there. So by oversight, I mean things like universal data stores, this kind of thing, and projects that span the whole company.
Yeah. So so that's the issue that I try to touch upon basically at the end. So what you can do, and what we've done with this one company, is to actually set up, let's say, a central data science excellence hub, so to say. And it's, in this case, it more or less became actually more of kind of a virtual team, where basically all of the data scientists that you have distributed in the company actually belong together. And I think this is really, especially when you have really large organizations where it is also needed that you might have, let's say, those smaller data science teams basically within the business units to kind of set up those. Sometimes it's also called circles of excellence or whatever, but you kind of need to make sure that you kind of have this discussion going on in order to make sure that you don't reinvent the wheel, and also, as you said, that you have kind of a unified kind of data structure. So I think actually that a hybrid system is possible, where you have kind of a more centralized unit. And in this case, also it's been the case that, so I was talking that they were basically lending out data scientists, but mostly they were not lending out data engineers. And that's kind of the interesting factor here. So what you can have is you can try to set up an organization where you have like all the data engineering force more at the center, to be more, let's say, the data provider, and also the unit that makes sure that the data products that you build are actually running, doing DevOps and so on and so forth. So to have this centralized, and then to basically have those decentralized data scientists as kind of satellites who have kind of a dual belonging, let's say, to the subject matter business unit and also to the central system. So at the end, I think it's possible. It can be done. Cool.
Can I quickly follow up on this question, Mark, and then you can continue, or do you want to follow up immediately?
No, sure. Continue.
Yeah. So actually, René, you kind of answered the question that I had, And this was basically, if you have these hybrid systems in large organizations, you kind of end up having to almost create your own IT department, to handle, unified data store, DevOps, all this kind of stuff. Is that something that happens, or do you then try to find models which would enable you to actually cooperate with IT? Because the IT is an existing organization. Or what would be more efficient? Are there trade-offs there or considerations?
Well, I think it highly depends, really. I mean, one thing is clear, and I'm not sure whether I mentioned this anywhere, is that as a data science team, right, you always somehow need to be close to the IT department, and if it's only, let's say, on a personal basis, but you need to get along well with IT, because at the end, most likely they are the ones who are, let's say, the source of the data, and you might aggregate it then in your lakes and so on and so forth. But yeah, I mean, it's a good question. If you have like really huge departments, it might make sense in this case actually to have, let's say, the data engineering workforce to be, let's say, super close to IT, and then to have this, let's say, kind of satellite system with the data scientists in the business units. But yeah, I mean, it's definitely a challenge, and I think it really, it really depends on the case.
Thanks. Mark, do you want to follow up?
Yeah, only just to add that I've also seen kind of where it goes too far, perhaps, and you end up with teams like a data management or a data engineering team that is close to IT and starts to do its own analytics, and then you get overlap here as well. So I think there's no silver bullet, of course, but yeah, it's worth raising some of the issues that can occur.
Yeah, absolutely. In fact, all these questions should also be an invitation to the participants to share their experience and opinions. And we have another question from NLP Zurich. Go ahead. You should be unmuted.
Yeah, it's Cornelia speaking. You just don't. Yeah, hi. How are you doing? You just don't allow people to change their names, so I couldn't do it on my phone. Thank you very much for the talk. And I love the idea of Uber doing rotations. However, once you go to a different business setting, a non-technical one, let's put it like that, I imagine me being in a product team, working with a data scientist for 6 months on a product that needs maintenance, updates, etc. I wouldn't let that data scientist go on a rotation. I would like to keep him. Her.
Sorry, you would like to what? I didn't get this.
So I don't want to get another data scientist or a group of data scientists, because I invested as a product manager, a product owner, 6 months teaching that person the business, the product, and having it in a rotational system would mean while the data science team would benefit from it, the product team would need to teach again and again.
Yes. Okay. Yeah. So So actually, there's a final, let's say, issue that I missed. The rotations there actually they worked for most of the teams, because very often when you work with someone, and in this case again it was a kind of new setting, you will have the task to build a personalization system for this and that, let's say, outlet, and you're going to be doing it. And after this, actually, not much of, let's say, product innovation actually happens. Okay, so basically, once you have something, so let's say if it's kind of a more of a finite project, which at the end, of course, needs tweaking and so on and so forth, but still that has kind of a start and an end. I think it makes sense to do this kind of rotation, because the product team will not have the need for one, let's say, data scientist to be working there 100% all the time. However, there might definitely be cases where you exactly have this, where you exactly have the need actually for one data scientist. And then actually what we proposed there is to say, hey, if this happens, then let's make sure that, let's say, from an organizational perspective, this one data science person, also from a headcount perspective, actually will be part of the product team. But make sure, make sure that this person still belongs, let's say, to the data science circle of excellence, you know, where you do best practice sharing and so on and so forth, and where you are still close to the data team. And I mean, in this case, it didn't go that far, but I imagine that it can work, because as a single data scientist in a product team, you will have the need, and I mean, you will have the need to actually talk to other technical people as well, to other data science people in this case. So I think basically there you would, it would be possible to kind of keep the discussion flowing, but it's definitely something that needs work to kind of make sure that it is like this. Yeah, I'm not sure whether this answered the question. But, yeah.
I don't think there is an answer, but I really like to hear different opinions, because I think nobody knows the,
yes,
you know, the right answers here, but it's always a challenge. Thank you so much.
Yeah, thanks.
I suppose it can also happen that at some point the product manager, he loves that data scientist so much that decides to hire him in a different role, maybe as some kind of expert or whatever, kind of token role, just so that he can have the data scientist. But there is no single answer to that. That's true. Now, I don't see any raised hands at the moment. Oh no, there is one raised hand. So go ahead, Afke. Oh no, sorry, I muted you by mistake.
So yeah, I just unmuted myself and then you muted me again. Don't worry. Good. Yes. So here, Afke speaking. What I think, I really like the discussion, and this is a discussion that I've been seeing out of my daily job, as well as the job I have at the HWZ, University of Applied Sciences. How to do this, and I think an important add-on. I think the hybrid model is probably the easiest one to go. I think it's important that there is at one place in the company, on a rather higher level of the organization, that there's a responsibility to drive this forward and to drive where and how the way that this works. Because I don't think that it will organically start to work in a way, right? So if companies start to hire data scientists into product teams without centrally being organized, that there is a community, it will be difficult. And I think also there are probably two different types of data scientists. I've heard terms like the citizen data scientist versus well, I guess the those that are very hardcore into the different type of models, versus a person who's really good in building dashboards. Kind of, if you look at that from the spectrum, that the person that is very good at the dashboard is maybe the better person to be on the business side on a product team, and the person who's very good in building sophisticated models rather in a central place that can be lent out for different products teams as well, depending on the need. And on top of that, what I've also seen in the market is that there are actually the central teams that work out of IT, but that they get specific focus areas. That, like, this is a team of data scientists that can, I don't know, for example, support sales and marketing topics, or can support operational topics, or things like that, with a specific focus, so that they can work on different projects, different parts of the organization, but do develop the business needs and the understanding of the business and the understanding of the company.
Yes. Yes. Yeah, no, absolutely. Yeah, absolutely. And I think this is also really why it's so important to kind of think in this matrix.
Exactly.
style, because you really will have different people in those different areas, and you need to be aware of this. Cool.
Cool. Thank you, Afka.
Yeah, thanks.
Now, I don't see any other raised hands. We're a little bit late, but given the fact that the weather is not that great, I think that it's okay. I think the discussion is more important than being precisely on time. I have one last thing, René, that I want to ask you quickly, and it's a little bit not so connected to the topics you covered, but more of a provocative question. So what I've experienced as well is that you're a data scientist, and then there is a team, let's say marketing team or any kind of team, who comes to you and says, well, you guys are data scientists, can you do this? And you say, well, yeah, we can do it. We would need a month. And they say, well, but there's this consulting company that tells us that they can do it in a week. And why don't we just outsource that thing and go with whatever consulting company is offering us? How do you approach this situation? Because there are, I mean, you know that consulting companies, they kind of really want to get in. So you know where I'm going with this, right?
Yes. So what we did, or what I usually say is that, especially when you start out with data science, it's a lot of, and it comes back to this fact that it's called data science. So there's a lot of learning involved and so on and so forth. And this is then most likely where I say, I mean, of course, they might say that they can do it within a week to actually build a, let's say, first version of the model. But the actual work, which is, to optimize it and to make sure that it's also being used, that is still something that you need to do in-house. That's number one. And number two is that if you have a data science team in-house, they will already have a lot of knowledge. So they will already know the business, they will know the people, they will know the data, and so on and so forth. And it's usually, I'd say, it pays off more if you have your internal data team working on it than external people, because they most likely won't know exactly the business and so on and so forth. They most likely will treat it as a let's say, kind of a black boxy thing. Data in, model out, but getting this kind of deep kind of business understanding might not work. Here, of course, still this is not always the case. I think the more, ironically, I'd say the more specialized the task, the better off you might be outsourcing it, or let's say have someone helping you with it. Yes, because it might just really be quicker. So let's say if you have something that you can define very well, I don't know, let's build a image recognition system for whatever, cats. It might be easier to have someone do it who built something similar already for 100 other clients than doing it in-house. However, when you have a case where a lot of business knowledge is needed, then doing it in-house is most likely the better option.
And if I may add, from my perspective, I think scoping is an extremely important task to do in any project, but especially if somebody is asking for fast delivery, or for fast delivery of a first version. What I mean by scoping is to make clear what can be achieved in some time. So rather to say, this is going to take us 6 months or 12 months, it's better to say, okay, let's start with maybe a scoped month, and the delivery of this month will be a first analysis on, let's say, the feasibility of the project. Do we actually have the data available in order to get to accomplish this task? Does the data have the quality that we need in order to get some sensible results from that, and so on? And this, of course, will not be the full delivery that the client or the business user would like to have, but at least it's moving into the right direction. And also this taking a scoped approach and phasing it in small iterations, some might even call it an agile approach, you can also involve the business or the client on a regular basis, which will also give them kind of an educative perspective on this, because they will also see the issues that come up. If the data science team goes back to their labs and keeps everything as a black box, and basically only comes back with results once they feel fully satisfied with it, the business will never really have the ability to appreciate the complexity of the work that goes in, and also not appreciate that the data is in fact the key ingredient, right? I mean, algorithms and models are important. Understanding the business processes is important. But at the end of the day, if you don't have the data that matches with all of this, no data product will ever deliver on the expectations.
Certainly, yeah, very good, very good. And I think actually that's, Patrick, that's the right time for you to proceed with your talk. I don't see any more raised hands, so let's move ahead with your talk. I give the floor to you now.
Thank you, Pablo. All right, seeing that we already 6:15, I try to speed up a little bit. But I would, yeah, still like to maybe focus back a little bit on what René has just mentioned, and kind of create the link from there to the technology side. What I will be talking about is models as data, a scalable data ops and ML ops approach using open source. And in particular, I'll be talking about the product that I've built from this called Omega ML. René has introduced the full scope of the organizational and business challenges around building a data product. And I would just like to briefly reiterate on that. Studies show that most data products and actually data science projects never make it from the lab to production. And there is a multitude of reasons for that. René touched on a lot of those. There is high complexity. It involves different skills. It involves different people from different departments, maybe even cross-organizational, even dealing with partners external to the company. There is a lot of technology involved, and in particular in data science, we have a lot of open source technology. Even if you buy a commercial service, you will be confronted with the complexity of integrating different open source products. Most of the commercial products are built from open source in some way or another, and that's an own challenge in its own right. And the technology is also constantly evolving, and so it's hard to kind of pinpoint what is the best choice. What I would like to propose today is using open source, and I've bundled that into this product called Omega ML. What it provides is basically a way to deploy machine learning and data pipelines effectively and easily, and it also enables some of the collaboration that we just discussed about that could actually help different data scientists collaborate more easily from different groups. Maybe a few words about myself. I have been working in the business intelligence space, as it used to be called, since the mid-90s. I've had quite a bit of experience building, well, maybe not data product in the modern sense, but somewhere related to data all the time. I've been involved as a software engineer, as a project manager, both on the business and the technical side. And so I've basically seen the full stack of what we have been talking about. Today I'm working as a freelance data scientist, helping companies productize or enable their data operations in general. Omega ML is an open source project, and it's also offered as a hosted and managed service. I think the particular thing about data products and any data science project, in fact, is that these projects never end. And that's a major distinction to traditional software projects. In traditional software projects, you generally have a project that starts with some requirements, and you have a pretty good sense of when it should end. and what those features, what the features are that you would like to have until then. And you can pretty much organize the team around that. And once the project is done, you deploy that to some production system, and then an operations team can take over and just make sure that this application runs. Of course, you have all that support organization, you have a maintenance organization, you need to make sure that bugs are treated and new feature requests come in, and so you have further development. But in a nutshell, a software product at some point is finished and you can use it. And with data products, that's quite different, because you start out with some vision that you want to deliver on. We've seen the different categories, and René has also touched on this. And you are never quite done, because once you have built a first version of your product, you will start using that with new data coming in. And you don't really know how your model is going to react to that, how your analysis is going to turn out, and how in the end your data product will provide value to your customers. And so you basically have to continue. We've also heard from Cornelia that she would actually like to keep the data scientists close to the business users, because they have kind of built a joint knowledge base on this product. And that's exactly, I would say that that's probably one of the reasons she would like to do that, because the knowledge is needed on an ongoing basis, much more so than in any traditional software engineering. René has mentioned that it's important to know what you want to achieve, and so the business objective is really at the beginning of this cycle. But it kind of comes back all the time. And of course, you have to do quality assurance in the middle. And now what you can see is, if I can move fast in this circle, so if I can go from business objective to delivery relatively fast, even if it's only a small step in the whole development of the product, I can deliver something tangible to the business much sooner. If every of those steps takes months, each of those steps takes months, you will never get anywhere. You will not get insight into data. You will end up losing a lot of time on organizing access to data, analysis of data, delivery of some product. And so it's important to be able to go through this cycle very, very fast. And that's a challenge, because the development is more a data science topic, whereas the deployment and running a system is more of a software engineering and DevOps IT topic. And that, I think, is actually a huge problem. And I would like to give you a motivating example of where I have experienced this very problem. I was involved in a startup that created a travel assistant, as in, you can go to some app and you can find your journey from one place or the other, independent in practice, in theory, independent of the transportation mode, and the system would predict, whether there was free seating in public transportation, or whether there was a traffic jam coming up, and what would be the best time for you to travel. The data that we took in was passenger itineraries, operator statistics, weather data, event data, all that kind of thing, and integrated that into a holistic model, or many models, in fact, that would provide this kind of prediction service. And what we found is that the data acquisition was a challenge, of course, but once that's done, that's relatively stable. And the machine learning side was also relatively straightforward, in that we could apply logistic regression and random forests that provided quite a good accuracy on a validation set. As a base model, that's pretty good, because if you think about predicting passenger load on a public transportation, if you achieve 80%, that's already better than a wild guess. And so that was actually sufficient to start. But what we found to be difficult was how can we run a system like this, where in the end we have hundreds of model instances. So you can imagine that every train, every public, every train, every bus, every road has its own model attached to it. And so the challenge that we actually had to solve was how can we deploy and run hundreds of models and run them productively in the cloud. And by productively, I mean also that you can retrain those models on an ongoing daily fashion without a data scientist in the loop for deployment, of course, for quality assurance, but not for the actual running of the model. And now let's maybe take a step back and think about what is actually a model when we talk about how we can deploy that. And this is a very simple example here with a linear regression model that basically takes the number of bedrooms of an apartment and it comes out with a rental price. Let's say that's a monthly rental price. And I'm choosing this model with just one feature and one target value just for illustration. The model is represented in the linear regression formula, and you have two parameters that the model will learn, right? You have M, in this case, using this data, we have 200 as M and B as the intercept with 100, and you can verify that this model will perform perfectly given this data. When you think about deploying this, what you actually need to deploy is you need to make sure that the system running this model knows that this is a linear regression model, and so it knows to apply this formula. And in order to apply the formula, it needs these two parameters. It needs to know M and B, but you don't really need anything else than that. In fact, I can put this into an email and send it to someone, and they will be able to run the model just using those parameters. They don't need to get the training data. They only need this data. And so when we want to deploy a model, it actually means deploying a software component that contains the name of the algorithm plus the parameters. And the way we would traditionally do this, if you go to your IT department or your software developer and tell them that, I have this model I want to deploy, they will draw some picture like this and they will say, okay, we can develop the system, and then at some point we will build some software package that we can install, and then we will deploy that package first, maybe on a development server and then on a test server, and when we are sure that it runs correctly, we will deploy that further onto the production system, and then we can run that. And when you go to them and you say, well, now my data has changed slightly and I need to update my model, they will say, no problem, just deliver the model. We'll go through the cycle again. We'll start developing a new release, we'll build that, we'll deploy that to the test server, and once done, we will, and when we're satisfied with the results, we'll deploy that further to the production system. And obviously that process works well. It has been tested, with software being deployed for several decades now. That's the way to run a software system. That's how the best practice looks. In the meantime, there is a lot of DevOps technology that helps you speed up this process, and in some cases also automates part of it. However, this feedback loop where you have a running system and it needs to go back and train a new machine learning model is not something that you can readily do. Also, of course, this takes quite a long time, even if you have automated it, because it involves a particular series of steps. In many companies, you also need to raise a change request if you want to go from development to test to production, and that takes time. And so there is a lot of organizational overhead attached to this model as well. Further, it becomes very difficult if you want to run multiple versions of your model. Let's say you have a version that performs quite well, but now new data comes in, and you need to retrain your model because you've found that it deteriorates in performance, in accuracy. And so you want to have a new version, but at the same time, you don't want to get rid of the old version altogether because you still want to compare results from the old to the new model. And so you have two versions of the same model, basically. And that's not something you can easily do with this model. And so therefore, the idea is to really look at models as data instead of code. And we can easily do that because, as we have seen before, in this example with the linear regression, all I need to know is the algorithm name and the parameters. I need to know it's a linear regression model, and I need to know M and B parameters in order to run the model. And really, that's just data, right? It's a name and parameters. Luckily, we know very well how to manage data. And when we do it like this, what we can do is we can run a production system that has a database of some kind, and it just receives algorithm and parameters as a package, stores it in the database. And then when I want to run the model, I just tell this production system that, hey, you know, I want to run this model. You have stored that in the database. And by the way, there is a version name to it. So that's version 1. And it will just look into the database and retrieve the model parameters and run the model and take the data that you give it and return the prediction. If you think about this, this has many advantages, because first of all, the process is much simpler. You still have to develop your model, but once you're done, you don't need to go and build some software package. All you need to do is package up the model name and the parameters and promote it to the production system. Because the production system is already running, you don't need to redeploy that. So there is no change request per se attached to it. You may still want to have some process governing this, but on an IT system level, this is no change, because the production system runs, there is the database attached to it, and it's perfectly fine from an IT point of view. Adding new data to a production system is a well-known concept, so no IT department will forbid you to do that. And so essentially the promotion becomes copying the algorithm name and the parameters of this model package, if you like, to this production database. You get many advantages out of this. It's short, it's light on engineering. You don't need a software engineer to do that. A data scientist can do that once you give it the right, give them the right tooling. And also you can easily do in production retraining with that, because you can imagine that once this is a production system that runs, you can basically ask it to retrain your model in production, because retraining basically means retrieving the data that describes the model. It means applying some new data, and once the model is trained, again take out the parameters that the new fitting process has generated, and you store that back into the database. Also, you can just add a new label to that newly trained model and call it version 2. And so you have version 1 and you have version 2, and you can easily retrieve one or the other as you like. And again, this can all run inside the production system, and you never need to go back to IT and say, you know, I have a need for redeploying. There is no redeployment as such. It's just a change in the database. In addition, it also solves some of the challenges that I have seen many times in companies, which is keeping the sort of software installation that a data scientist needs centralized and ready to go. If you run a single system that provides all the capabilities to run data science projects, then you can centralize all the engineering that goes with that, and you can also enable collaboration among data scientists on that very same platform. So I think that the models as data approach has quite a bit of advantages. Now, you may ask, and I announced that in terms of the open source part, what do we need to get there? And surprisingly, everything is actually there. Nothing is missing. If you look at the machine learning part, of course, we have all these great packages. If we look at the pipeline building part, we also have a lot of packages, and this is just a few of these. If we think about storing data and models in particular, we have many choices to choose from, many different type of databases, NoSQL or SQL versions. If we look at how we can deploy products, there is a lot of great technology to do that, all open source. And if we look at how to deploy systems, there is Docker and Kubernetes that have gained widespread use over the last, I don't know, maybe five years or so. And that's also kind of a solved problem. And if we look at the Python environment to run code in the cloud, there is also a multitude of technologies. Of course, the challenge is you need to somehow integrate all of this, and that's really what I've done with Omega ML. And the way Omega ML works is by basically keeping the existing open source packages intact. So you keep on using what you have already been using so far, Pandas, scikit-learn, Keras, TensorFlow, Plotly Dash, or any other open source technology that you like to use. And Omega ML doesn't change any of that. What Omega ML provides is the infrastructure that you need in order to deploy and collaborate on data, models, notebooks, and using the cloud for running your jobs. And by the way that Omega ML does that is it provides you a simple Python API that you can use to get objects, to store objects, or to list what you have stored. And there are three ways you can store things. You can store data sets. So that's, for example, a Pandas data frame. And you can readily store that. You don't have to somehow transform it or find some database API to do that. You can just basically take your data frame and put it, and it will be stored in this data sets namespace. And you can also store models. Again, you can take your model as you have it in, let's say, a scikit-learn model, linear regression model, and you can just store that. And similarly, you can store a notebook, Jupyter notebook, and have that execute as a job on your cloud cluster. In the backend, Omega ML will by default use MongoDB, but it can also integrate with any other database or file system. Also, Omega ML keeps track of what it stores. So there is a metadata layer which knows what it stores. So you give it a name and it remembers that name, and it will also remember what type of data or what type of model you have stored. And it will use a plugin to retrieve that back once you want to do that. I'll give a quick demo on this part. What Omega ML also provides is the so-called runtime. And the runtime is really a simple interface to your cloud infrastructure, to your computational resources. So instead of running your models or training your models on your laptop, you can use the runtime to train a model on the cloud using cloud-provided resources. That could be, it could be on Google or Amazon, or it can be in-house in your own cloud, or it can be any other server that has the Omega ML system installed. We will also see that in the demo. In fact, regarding the demo, what we will do is I will create a simple linear regression model similar to the one I have introduced before. We will deploy that model in an untrained version to the cloud. We will then load some data, train that model, and we will use the REST API to run predictions from that. And for those of you not familiar with REST APIs are basically web URLs for machines. So any application can use that, whether it's a smartphone application or a web application. Once you have a REST API, it means that your system will be able to interact with that. With that, I will switch to an editor. And I'll go through this very quickly and briefly. Please bear with me. The details don't matter so much, I think, but the process does. What I'm showing you, for those not familiar with Python, is a simple program that creates a linear regression model. And the objective is to have a model that takes, as shown before, the number of bedrooms and produces some monthly price regarding that. What I'm creating here is an empty linear regression model. In other words, it can't do anything by itself. And what I'm doing now is I'll store that model into Omega ML, the cloud version of Omega ML. And I'm doing this by executing this command. What I'm saying is, Omega ML, please use the models namespace, and I want to store something, so put it, and the name of what I want to put this is here, and I want to name that model reg model, regression model. And what OmegaML does is it takes that little piece of code that I've shown you before, it executes it, and then stores the resulting model into its database. And it comes back by saying, okay, I've now stored that model as reg model. And by the way, I found that this is a scikit-learn model. So whenever we want to use that, we can now you can now access that model under this name. And in fact, I can now go to my colleague on the team and say, you know, I've created this model, you can go and use it. And my team member could go to his Jupyter notebook here and just get back that model by executing this simple command. And it will simply come back with the linear regression model as you would expect it. So of course now this model doesn't do anything because it's untrained. So when I try and execute the prediction, it will now say, sorry, but this has not been fitted yet. And so, you know, my colleague would probably come back and say, yeah, nice, you have given me this model, but you need to train it, otherwise I can't use it. And so that's what I want to do next. I want to load some data and train that model. And the data is similar to the table that I've shown in the example before. You can imagine that the first column here is number of bedrooms, and the second column is the monthly price that I give the model as training data. And you know, you can easily see that this is a simple multiplication by 50. So that's what this model will now learn. And in fact, I can do this by executing another command. I can ask OmegaML to use the runtime, which now means that this training is actually running in the cloud. I want to use the reg model that I've just stored, and I want to train it, fit it. And I do that by using the sample data set that I've just declared. And I want to use the X and the Y column. In fact, if you've been wondering how I stored this data, I previously did that by executing this command. I took the CSV file that I just showed you, I gave it the name sample, and I replaced any previous version from that. And in fact, I can look at that data if I want to, and just get back that sample model. And you can see it's a data frame, pandas data frame that just contains this very data that I've entered. And now when I go back to my colleague on the team and say, yeah, I've now trained the model, he can retrieve that model again on his Jupyter notebook and run a prediction. And obviously we need to make sure the technical parameters are right. And he can give the numbers of bedrooms and get a monthly price. And I can now also, give it some absurd numbers, and it will just do the multiplication by 50, because obviously that's what the training data has said, and so that's what the model has now learned. And I can also use the REST API to do that. And here I'm using a tool called Postman, but that's actually not the important part. The important part is this URL, which is the address, the web address of the model. And you can see I've specified the name here, and what I want to do with it is predict. And I give it a list of bedrooms that I want to predict the price for, and I'll just send that off. And as before, it will come back with a list of prices it has calculated. So if, just for the sake of showing that this is live, I can also give it some other, let's take a number that we haven't yet, some other value, and it will just come back with that very result. So as I've said, what we've done is we trained the model in the cloud, and we've accessed that model. And what has happened in the background is basically, as shown here, when I stored the model, this was stored on the distributed file system in OmegaML, which is the cloud version. when I put the data set, it just stored that data frame into its storage. And when I fitted the model, what happened then is it talked to the runtime. The runtime dispatched a task to what is known as a runtime worker, which is just a process running on the server, and it stored back the result. And similarly, when I predicted that, it just retrieved the model back into the runtime worker, executed the prediction, and sent back the result through the REST API. Now, if you think about this concept of storing models as data into a database again, obviously you can easily have multiple versions of that model. You just give it a different name in the very beginning. And that's actually what OmegaML supports easily. You can just give different names to models. You can store as many models as you like. There is no limitation other than space in the database. But OmegaML also provides an addition to that, and you can actually version your models. And so you can give, you can have the same model name with a version name attached to it. So it can be reg model version 1, reg model version 2, and so on. And OmegaML will, in the background, manage the multiple versions for you. This is currently available as a preview. And if anyone is interested in using that, please let me know, and we can work something out for you to use that already. Last but not least, I want to maybe emphasize one aspect that has also somewhat come up in the previous discussion with René about the different people involved and the different roles. And I think that a platform like OmegaML really helps to enable the organizational part as well, because you can focus the skills on specific tasks. What I mean by this is once you have a platform like OmegaML, you can have your data scientists and data engineers work on their pipelines, on their analytics, and also deliver models and other parts of the system in an easy fashion. You have seen that we could easily store data frames and retrieve data frames back, store models and retrieve them back, access them through an API, and that has all happened instantly. In other words, it didn't require a software engineer to add any component to that. And so your data scientists can really focus on this layer. Whereas if you have a software engineer on the team and they would build, maybe a smartphone application or some application on the web, then they can also work with this very easily because they know what a REST API is and how to use that, but they don't necessarily know what a model is. But by giving them a REST API, they can just easily use that without caring about all the details behind it. Similarly, for if you have a platform engineer, a DevOps engineer, they can concentrate on providing, what is here grayed out a little bit as the background architecture, which contains the databases and the computation nodes. And so platform engineers can really manage all the platform side without having to become a dependency for the data scientists and data analyst teams to work with them. So in a nutshell, I think having a platform like OmegaML helps your organization to focus the skills and therefore also make it more productive for the organization to perform data analytics. Also, maybe in the collaboration side, when you want to have multiple departments talk to each other, it also helps to have a centralized platform where everything is stored and managed in the same manner. If you find this interesting, please feel free to reach out to me, or you can actually get OmegaML from GitHub. It's open source. Everything that I've shown you today can readily be used from an open source package. It's Dockerized, so you can install it anywhere basically. Or if you prefer a managed service where we run everything for you, then that's also a possibility. Or if you need to integrate that into your own IT department, into your own company on premises, then you can also do that, and we have options available for that. If you find the models as data approach interesting, I've written a article that was published on media towards data science, and you can read more about that in this article. And I would be very eager and interested to hear your feedbacks and thoughts around that. With that, I would actually like to conclude my talk and open up for any questions that you may have.
Thanks, Patrick. I'm scanning the list for raised hands, or you can just unmute yourself if you have a question. Again, I'd like to get the ball rolling by asking the first question. I take that as the privilege of being a co-organizer, so you have to live with it. Patrick, could you go back to your slides where you showed the running multiple versions of a model? You had the exactly this one. Okay. So the question is, in the beginning you talked about this production system, and it sounded like the production system is not just the execution environment, but it would have to have some logic in there. For instance, in that graph here, you have, for example, let's say you want to test, want to do A/B testing, so you must have some kind of routing logic that routes requests to different models according to some ratio that you predefine. You also talked about let's say retraining the model live in production. So there has to be some kind of logic where you say, all right, I want my models to be automatically retrained with the last week worth of data, for instance, if it's some kind of time series model. This additional logic that sounds to be needed, is that part of OmegaML, or do you plan to work in this direction, or how or am I right that this is at all needed?
I think you're absolutely right that this is needed. So what OmegaML provides is the infrastructure to build that. It doesn't provide the logic that you're referring to, because that's, at the end of the day, that's, I would call it business logic, but it's logic in specific to a particular case, right? What OmegaML provides is the tools and infrastructure in order to build that. Specifically, for example, you can attach what is called a virtual function to any model, which acts as a translator. So instead of returning the actual result that the model predicted, for example, you can translate that into some other value. And in the course of that translation, you can, of course, also look at different results from different model versions and combine that in some way. And so that's how one way of implementing this logic. Another way is OmegaML also provides a Lambda style facility. So you can deploy essentially some piece of code, a method in Python terminology, and you also get the REST API for that. Or in fact, you get many different kinds of API. REST API is just one of them, and you can use that to implement the model. As a third part, there is a streaming component in OmegaML where you can define a stream function, and that stream function can execute any logic that you like, including running multiple model versions and then taking a decision on that. A stream function basically receives a batch of data. A batch can be as small as one record, or it can be batched by any criteria. For example, the last, I don't know, 10 records received, or the last 5 minutes, or something like this, and then execute whatever your logic needs based on that piece of data, and then send back a result. So in essence, what you get is kind of the elements that you would need. You can store models, you can add virtual functions to add translation, you can have Lambda style functions to add logic, or you can have streaming to add logic to smaller batches of data.
So basically you have some kind of primitives that you could use to build high level application or logic.
Yes, you can call
on top of
that way.
Okay. Good. Any questions? Let me scan quickly the attendees list. There is a raised hand from Patrick. Patrick, go ahead.
Yes, thank you, Pavlin. I have a question concerning the versioning you mentioned. Let's say maybe I missed it, but let's say I'm a user and I have different models which I use, which I run frequently to do some calculations on. And let's say I'm in a project. I have used specific versions of these models, and I want to do, and I have a result, and that's good, and I want to do all the same calculations at a later point of time. And now maybe there was an update on one of these models, or even more models, and now the result is different. So how, as from a user perspective, how get I kind of informed about maybe new versions, or how can I handle kind of this issue when something has changed and I want to have the same result as I had maybe a few weeks ago?
So I think what you're mentioning, actually, I would put into the quality assurance part of, from a methodology point of view. If I understand correctly, what you want to know is, if you have multiple versions, how can the system somehow detect that there is a difference between old and new? Is that correct?
Yes, exactly. Yeah.
Okay. So currently, OmegaML doesn't have a feature that does that automatically. What you can do is you can collect the data that flows into a model, as well as the predictions that it generates, and you can compare that to a baseline model, for example, by executing both versions of the model at the same time. So you would see your old model predicted, let's say, one number, and your new model predicted a slightly different number, and you can compare those two. You would still have to write the logic around that. What do you do with this information? Do you send that as an alert to your users, or do you have your data scientists look at that? What OmegaML provides in that is really the the tools to achieve that, but it doesn't have like a dashboard currently. But it's actually a feature that I would like to integrate. Probably not building it myself or from our perspectives, but we would want to integrate with something like MLflow, for example, which has a nice dashboard providing this kind of metrics. Does that somehow answer your question?
Yes, thank you.
Thanks, Patrick. I think Cornelia tried to unmute herself. Maybe wants to ask a question.
Yes, thank you so much, Patrick. It was very interesting. It made me wonder how it would work with the customer in the loop. Let's assume that we are executing multiple models. And based on the customer feedback at each step, we would need to choose a different one.
A different model?
Yes, so let's, I don't know, just a basic idea. First model executed, I give feedback as a customer. And based on my feedback, the next stage in the product is being executed, or the next model. Kind of actively learning based on customer feedback.
So it's some form of decision tree that. Okay. Interesting question. I think it depends a little bit on the nature of this, let's call it the decision tree, if that's a learned decision tree, it can also be a model itself.
Another model, yes.
Yes.
That's what I was thinking.
and that actually that's another advantage of having this models as data, because in real life systems, I think you will often come across this very problem that you're describing, that you end up having multiple parts of the system that somehow need to collaborate, and each part is a model in its own right. And then your front-end application needs to kind of either trigger a central service that has a logic in it that decides which model it needs to talk to, or your front-end does that by itself. And from a perspective of OmegaML and models as data, this decision model can be deployed as a separate model, or it can be part of a pipeline of models, where, you know, maybe you have, let's say, a logistic regression model that feeds into this decision tree, and then the actual prediction that you want to get back is from the decision tree. Yeah, but off the top of my head, that's one way I could think about this. Another approach might be that the logic is more involved than just using the models in a pipeline fashion. Maybe you want to look at you know, the model confidence in terms of probability that regarding the decision that it returns, and you might want to take a decision on that probability. And then you need more logic around that, and then the lambda style function would probably be more appropriate to use. Does that help?
Yes, yes, thank you. I'm not sure you heard me. Do you hear me?
Yes, I did.
Oh, okay, okay. Thank you very much.
My pleasure. Maybe one thought in extension to that. When working on this project I was initially describing as the motivation, the travel application, working with a team of data scientists who were actually part of a research organization. They didn't have the software engineering skills to deploy models, right? I mean, it wasn't their focus, it wasn't the purpose of their work, and we needed to find a way so that it was easy to take a model that they built and put it into production without going through this whole life cycle of building a software package and then deploying it. And that to me is an advantage of having a central system that provides a data scientist with the ability to deploy both pipelines as well as models in one line of code, essentially, without all the details. And then, you know, what I want to say regarding your question, Cornelia, is when you come to the conclusion, oh, I need another model, you don't want to go back to IT and say, oh, by the way, we forgot to add this model, and, you know, now we need to restart the project. What you actually want to do is a simple way to deploy this additional model and build it into your process. And that's where a system that basically keeps track of models as data is more flexible than a fully fledged packaged solution.
I also think it's a very good timing for a product like this, because most of the data science teams are coming out of the incubation time and realizing that, oh, there is a deployment issue.
Mm-hmm. Yes, precisely. I mean, deployment is a big thing, and I think that's especially what Mark talked about last time. Mark, go ahead. You can unmute yourself. No, you haven't done it yet.
Yes, I have now.
Go ahead.
Thank you. Cool. Yeah, thanks. That's yeah, it's really interesting, and yeah, everybody's quite right to point out that the deployment part is really that's where it gets difficult. Training models is relatively easy. Getting them used is the hard part. I think I'm interested in the models as data concept, and you've pointed out that the traditional method, of course, has some benefits like the models are versioned along with code, etc. But there's also, at least I see as a hybrid. And I'm wondering, what's the fundamental difference between what you've described as models as data and something involving TensorFlow serving or KF serving, for example, where a model is still trained as part of a versioned code base on data pulled from a versioned database, but that final model is then essentially served from a binary file still. This seems to be the best of both worlds, or am I wrong?
From my perspective, but obviously I'm a bit biased. It's the time and skills components that are different. You know, if you look at this from a software engineer's perspective, then storing a model into some file and putting it into a GitHub is an easy step, right? That's what you do all day anyway. So it may not look like a lot of overhead, but if you're concentrated on the data science part and the machine learning part, and you may not even have a background in software engineering, you do have some software development skills, but you may not be familiar with all the steps that are traditionally part of software engineering and even DevOps, then that's a complexity hurdle. It's not that you can't do it. I mean, intellectually, you're absolutely capable of doing that, but you don't have the time and focus to go into that. And that's where I see the major difference, because using models as data combined with a system like OmegaML that provides a simple way to transform a model into an entry in a database, you can completely eliminate all the complexity of, you know, transforming the model into some format, putting that into Git, triggering some CI/CD cycle, and then deploying that package that comes out of it as a tensor serve or some other MLflow kind of artifact, for example. Did I answer your question?
Yeah, I think you did. I get it. Yeah, this is definitely a time saver when the skills are not available. So yeah, cool. Thank you.
Sure.
I'm scanning the attendee list for other raised hands. Go ahead. And Mark, I lowered your hand so that I don't get confused. If there are no further questions, maybe we could start wrapping up.
Yeah, I'm fine. Thanks very much, everyone, for your attention. Pauline, if it's all right, I would close with a few words.
Sure, sure, of course.
First of all, Pauline, I would like to thank you and René for doing this and giving the opportunity to co-host. I think it was a very interesting experience from a Zoom perspective, but also I think it was great having the opportunity to conduct this meetup despite all the coronavirus difficulties. I would like to mention, Pauline, what you mentioned to me when we started talking about this, and please correct me if I'm wrong about this, but there is kind of an open call to anyone on the group now or later to come forward and also co-host or present something. Pauline has made sure that this is an open kind of forum. So please, you know, if you're interested, reach out to Pauline, myself, or René, and we're happy to connect you with the required resources. So with that, thank you all very much for taking your time, and have a great time. Stay safe.
Thank you, everyone.
Yeah.
Thank you.
Thank you. Thanks for organizing.
Great job.
Thank you very much. Thanks.
Thank you.
Yeah, thanks everyone.
Have a nice evening.